Good afternoon, everyone. Thank you for joining us today to learn more about the Industrial Demonstrations Program and the recently announced project selections. My name is Kelly Cummins, and I am the Acting Director for the Office of Clean Energy Demonstrations, commonly referred to as OCED. Before we begin this session, I want to go over a few webinar logistics. You can turn on live captions by clicking on Captions in your control panel. To turn on Spanish or ASL interpretation, please click on the Interpretation button in your control panel. Finally, you'll be able to find a recording of this webinar and a copy of the presentation slides on our website in the next few days. My team and I are so pleased to be speaking with you today about the industrial demonstrations projects that we have selected to enter into award negotiations. We at OCED are eager to share more about the program and the potential of these industrial demonstrations. In this briefing, we will summarize each of the 33 selected projects. We will also want to explain what you can expect next, including upcoming opportunities for engagement and more information about our negotiations process. While we're not taking questions today, we invite you to share your perspective and feedback through the email address that we will provide at the end of this presentation. OCED will also be co-hosting 5 additional virtual regional briefings in April for local communities and interested stakeholders to hear about the selected projects in their area. Details will be shared later in this webinar. The United States is committed to addressing the climate crisis and leading the global energy transition, which is why President Biden set ambitious goals for our nation to achieve a net zero economy by 2050. The energy and carbon intensity of the industrial sector contributes to nearly 1/3 of the nation's primary energy-related carbon dioxide emissions, representing a unique and complex challenge to decarbonizing the nation's economy. The Bipartisan Infrastructure Law and the Inflation Reduction Act provided up to $6 billion for industrial demonstrations projects to accelerate transformational decarbonization technologies in our nation's energy-intensive industries. This funding is managed through OCED's Industrial Demonstrations Program. Just this past Monday, DOE announced that 33 industrial demonstrations projects have been selected to enter into award negotiations. DOE is committed to ensuring these projects create real economic and environmental benefits for the communities and workers where they are located. This is why we have worked hard to develop a community benefits framework that reflects the administration's strong commitment to provide historic support for underserved communities and deliver on the Justice 40 initiative. The benefits that these projects deliver to their communities, which we will discuss in this briefing, are expected to go beyond a vision or assessment and align with the needs and priorities of impacted communities and include actionable goals, outcomes, and clear metrics to measure success. The success of our clean energy transition requires communities and tribes to be consulted and engaged often and regularly. It will require transparency and accountability and new approaches to solve old and persistent problems. We also know this transition presents vast opportunities to build a better economy, create millions of good-paying jobs, clean our water and air, and ensure all Americans can live healthier, safer, and stronger lives. Because of this, we are truly excited about the potential for these industrial demonstration projects to do good for our communities, for our nation, and for our climate. Before we get into each of the selected projects, I'd like to share more about the industries and technologies within the Industrial Demonstrations Program. Let's start by understanding the challenge of decarbonizing the industrial sector. U.S. industry is incredibly diverse, with emissions resulting from fuel needed for heat and power, as well as feedstocks and processes. Plants require a high level of reliability when it comes to their energy to keep operations running 24/7. Industry has long been described as difficult to decarbonize due to the fact that there are outstanding challenges beyond the technologies that are available widely today to take these sectors to net zero. That's what we're looking to solve with this funding. Heat is one of the biggest challenges in the industrial sector. Many industrial processes rely on a consistent source of heat. And in the case of energy-intensive industries, that heat is often needed at high temperatures and is largely produced through the combustion of fossil fuels. The industrial sector is one of the biggest unsolved clean energy transition challenges and one of the most substantial opportunities to reshape the U.S. economy and reinvigorate the U.S. manufacturing sector. This investment in new emerging technologies will help produce clean steel, cement, and chemicals used in our nation's roads, bridges, transmission lines, electric vehicles, solar panels, and wind turbines, which in turn benefits every American. OCED's Industrial Demonstrations Program represents a more than $20 billion public and private investment to accelerate transformational decarbonization projects in our nation's energy-intensive industries and position American companies as leaders in the clean energy economy. This $6 billion catalyzing federal investment will help buy down risk in the highest emitting industrial sectors by applying a wide range of technologies, from energy efficiency upgrades and electrification to enabling hydrogen-ready fuel switching and carbon capture, utilization, and storage. This program offers a critical opportunity to solidify a first mover advantage for US industry, positioning American companies as leaders in the clean energy economy. By implementing these projects, US manufacturers will produce many of the world's cleanest goods, which will be sought after both domestically and for export internationally as global consumers, businesses, and individuals increasingly demand transparency about carbon intensity. So how did we get to this stage? Last March, about a year ago, OCED put out a funding opportunity announcement for the Industrial Demonstrations Program. And this turned out to be an incredibly competitive funding opportunity. We reviewed 411 concept papers in response to this funding opportunity that requested more than $60 billion in federal funding and proposed about $100 billion in matching private cost share in total. OCED encouraged 130 concept papers to submit full applications and received 110 full applications in August of 2023. That brings us to today. Since August, we've conducted a rigorous merit review and interview process, resulting in the 33 projects being selected for award negotiations for up to $6 billion in federal funding, which would be matched by $14 billion in private cost share. OCED's funding opportunity had 4 overarching goals, and I'm pleased to say that the portfolio of projects that we have selected have over-delivered on all of them. When we published this funding opportunity, we set ambitious targets, especially for the types of industries that were eligible to apply, at 50 to 75% emissions reduction per project. I'm pleased to announce that our selected portfolio has an average 77% reduction in carbon intensity and over 14 million metric tons of carbon dioxide emissions reduced each year. Many projects are pushing towards net zero emissions. We also prioritize timeliness. Understanding the urgency of this challenge, we wanted to make sure our projects could make an impact as soon as possible. And we wanted to accelerate solutions that industry previously thought it could implement in the 2030s or 2040s. We wanted to accelerate them into this decade. That's why I am so pleased that our selected portfolio has an average performance period of less than 6 years. Market viability for these solutions will also be critically important, and we know that premiums associated with greener products are still being established. Our selected OCED portfolio includes more than 35 projects that will be produced with lower embodied emissions. Several have offtake agreements already in place. This is an incredible achievement, especially with goods that will be produced in this portfolio many years out. Finally, we prioritize projects with the greatest benefit for the greatest number of people, especially as it relates to community health. We know that while industry provides good jobs and serves as the economic heartbeat of its communities, it has also resulted in pollution that has disproportionately harmed disadvantaged communities. We are proud to say that 85% of projects will reduce criteria air pollutants, which can harm humans and environmental health. Additionally, this investment will create tens of thousands of jobs. While over $20 billion is a huge advancement in industrial decarbonization, it is only about 2% of the total $1 trillion investment needed to decarbonize the industrial sector. Early commercial deployments of decarbonization technologies in the sector-specific applications could drive cost reductions and encourage cross-sector learnings, which could boost the value proposition of similar future projects. I'm proud to say that these projects are catalyzing the scale of investment needed to meaningfully decarbonize industry. With that in mind, let's turn to the projects we've selected to accelerate industrial decarbonization across the United States. Now that you have more context for the program and how it fits into our climate and equity goals, I will turn things over to Todd Schrader, the OCED Director of Project Management, to share more details about the projects we've selected.
Thank you, Kelly. And as Kelly mentioned, 33 projects were selected, and we're going to very quickly discuss them today. They're across multiple industries, including iron and steel, aluminum and metals, primarily copper, cement and concrete, chemicals and refining, and some cross-cutting heat projects themselves. One thing I will note as we go through these slides, most cases the location is shown. In a few cases it's TBD or something similar, and that's because we're still determining these very specific project sites in a few cases. So you might see that on the slides themselves. So next slide, please. We'll start with iron and steel. 6 projects were selected in this area to demonstrate emerging technologies. And one of the things you'll see, I think, across not just steel, but all of them, these improvements come in a couple of different types, whether it's new fuel, substituting fossil fuel for hydrogen fuel or cleaner fuel, or the process itself has changed to be more efficient, or the backside, recycling is increased, or a reuse of the products are available. And so you'll see that, I think, across all of our projects, and we'll talk again specific to iron and steel here going forward. But I think that's just important to show the real breadth of potential decarbonization solutions that this program is looking at. It's not a one-size-fits-all. It's get all the tools possible for the decarbonization. So you see there 6 projects, $1.5 billion total investment. And these projects alone have the potential to avoid nearly 2.5 million metric tons of carbon emissions each year. So with that, let's go next slide, please. We will start in Ohio, Middleton, Ohio, at Cleveland Cliffs Steel Corporation. The project there, you see the name, and it's this is a good example of changing out the process itself, moving from a fossil fuel process for heating steel to a direct reduced iron process that uses electric melting furnaces. So significant reduction in carbon emissions from this, up to 1 million metric tons per year going forward. It also will source the material from domestic sources. And it's often the case you see with, and you'll see this a couple times, with a fuel sourcing or going to an electric source versus a previous fossil fuel source. You also get reductions in oftentimes water, the air itself, other pollutants such as SOx, NOx, particulate matter, et cetera, are also reduced. So you get better overall water and air emissions. So next slide, please. So the SSAB project in Perry County, Mississippi, and then an off-taker in Montpelier, Iowa. This is again, a zero emissions steelmaking process with the original plant in Mississippi there, and it's a direct reduced iron technology with 100% hydrogen as the source of the power. And then the plan to expand it into other facilities or to take the steel into other processing facilities such as Iowa. Again, this has the potential to reduce up to 81% of potential GHG, and you can see quite a few jobs associated with this work going forward. Next slide, please. The Vale USA low emissions coal amalgamated iron ore briquette production project. It's on the Gulf Coast, and it is an iron and steel project. And it's a first of a kind facility for low emission alternatives in the versus the traditional use of iron ore pellets or how they're used itself. So it's a little bit different than the process itself. It's some of the material itself and how it's being used going forward. Again, looking to reduce the amount of industrial heat, which itself reduces your CO2 emissions and reduces the power required for the process. So overall, estimated 60% reduction in CO2 emissions, and some, like I mentioned before, in this case, SOx or sulfur oxide, a 99% reduction. And again, you see quite a few number of jobs associated with this project. Next slide, please. Project in Bessemer, Alabama. It's the iron electric induction conversion project, part of the United States Pipe and Foundry Company. And in this case, it's replacing the furnace itself with an electric induction melting furnace. So similar to it's changing the process material itself and how that power is fed into into the process. But in particular, it's eliminated the need for the natural gas and coke part of the process. 73% reduction in carbon intensity for this operation itself. It's quite a few number of jobs, and similar to what I mentioned before, overall air quality is also increased with the changing of how you're providing heat or power to the plant itself. Next slide, please. Next one, we're in Birmingham, Alabama, not that far away. And this is the American Cast Iron Pipe Company and their induction melting upgrade. And so it's upgrading a current plant. And I should have said, most of these projects you see are upgrades to existing plants. In some cases, they're new facilities, but almost always they're, almost all of these are upgrades to existing plants themselves. And so they're replacing their existing furnace with 4 induction furnaces that are electrified, and it eliminates the use of some coke, which is derived from coal, in the combustion process, and resulting emission reduction of up to 95% for the facility itself. It also, this is a good case where they have a longstanding relationship with local universities, and would expect that to continue going forward. Next slide, please. And I believe our final steel project, Cleveland Cliffs, this time in Lindora, Pennsylvania. And it's specifically their Butler Works project. And it's electrification of their production facility for high silicon grain oriented electric steel, which has some specific uses. This becomes a furnace. It's a furnace installation process. And so it may result in the processing itself of up to 100% reduction in the greenhouse gas emissions from the high temperature reheat furnaces that are currently used there. Quite a few jobs associated with this facility also. Next slide, please. So now we'll move on to cement and concrete. And this is a particularly exciting one in that not only can you reduce your carbon footprint or carbon intensity for the process itself, so basically move it down to, in the best case, 0% carbon produced. You may actually, because concrete itself uses carbon, you can get net negative, where you're actually pulling more carbon out of the atmosphere or storing more carbon than the process itself. So it's actually considered what we call net negative, which is a particularly exciting process because cement itself is one of the single largest sources of carbon globally. So lots of capability to get vast benefits and decarbonization benefits from this, and a very much replicable set of projects and potential changes to the industry. Overall investment is $1.6 billion. And for all of these projects we're about to discuss, 6 of them, upwards of 4 million metric tons of carbon emissions avoided each year. So onto the projects. Next slide, please. We will start in California at the National Cement Company of California, and their specific project is the Net Zero Cement Plant project itself. And it's it plans to produce a carbon neutral cement. And so again, instead of using fossil fuels in the process, they'll use some biomass, local biomass, and you can see a couple examples there. And they produce a limestone clay, excuse me, for the cement that has the ability to capture and sequester, and will capture and sequester some of the remaining emissions from the plant itself. So next slide, please. Back to Indiana, and this is the Heidelberg facility in Mitchell, Indiana, and it's the cement plant decarbonization project itself. And this is a case where I mentioned, I think before, a carbon capture and sequestration, CCS, as it's often called, where the plant itself, they're going to capture through point source technologies the carbon dioxide out of the exhaust flumes or the smokestacks, if you will. and then sequester it, geologically sequester it deep underground itself. This will prevent upwards of 2 million tons of carbon dioxide per year from entering the atmosphere during the operations of this facility itself. Again, quite a few jobs that you can see there going forward. Next slide, please. The next facility, a number of different facilities, potentially across the country. And these are new calcination facilities for Summit Materials here. And it demonstrates the viability of displacing limestone-based cement with clay-based products. So what it is it's cleaner source material or raw materials going into the projects, or less carbon-intensive raw materials being used to make the cement itself. Has potential for preventing upwards of 1.1 million metric tons of carbon emissions per year. And quite a few jobs, either directly or excuse me, indirectly associated with the project going forward. Next slide, please. Brimstone Energy. This one is a decarbonized cement plant. Location, I mentioned before, some of these are still being worked out. But it's a case of, again, a commercial scale plant that changed the way the cement is made, and it's source switching again. So they're using a calcium silicate rocks and alternative production methods as opposed to sort of the normal way that cement is used. And it has potential to avoid 120,000 metric tons of carbon dioxide each year going forward. So again, example of, it's not the process change as much as some of the source material and other things associated with it. And you can see a number of jobs associated with that facility also. Next slide, please. Up in Massachusetts, Sublime Systems Inc. It's electrochemical cement manufacturing. And so just a good example of, again, replacing more fossil intensive processes for producing high heat. It replaces the carbon limestone with the calcium silicate based feedstock. So again, a little bit different change in the how the material is made and the source material, raw material used in it going forward. Not quite as big a project. You can see smaller cost share there compared to some of these that we've seen, but still being able to produce a fair amount of jobs going forward, and certainly another potential replicable process itself. Next slide, please. Out to Virginia, the Roanoke Cement Company. This is the limestone calcined clay cement production process itself. And it's, again, kind of looking at the calcined clay in the region and how you can use that in the cement production facility. So raw material substitution or switching, potentially reducing the carbon intensity of the process by up to 83% going forward. Again, not a particularly large project, but certainly one that, particularly in that area where there is a abundance of this clay, that has real replicability potential going forward. Next slide, please. So now we'll talk about chemical and refining. So these projects, there's 7 of these projects, and we'll talk also about one pulp and paper project itself. And chemical processing is very carbon intensive, can be, and so it's one of the largest industrial sectors in the world. So turning its carbon intensity, addressing it, has a real potential to have a real impact itself. We can have we can increase the sort of circularity, or how we use waste products, get them recycled back into the system. There are ways we can onshore critical supply chains for some of these chemicals themselves also. It's a $1.3 billion investment in these projects themselves. Again, 8 total projects, counting the pulp and paper itself. And again, I mentioned there's some recycling, replacing of fossil fuels for high heat processes, decarbonizing fuels. And across all of these projects, potential is avoiding nearly 3 million metric tons of carbon emissions annually throughout each of these projects themselves. So let's talk briefly about them. Next slide, please. Down in Longview, Texas, we have the PET recycling decarbonization project going forward. It's the Eastman Chemical Company, and it's a recycling endeavor in that the company can use some of the products that maybe would have gone to landfill or other materials like that. They can recycle them back into the process themselves and turn them back into high quality virgin PET for use in other products after that. They also plan to use the thermal storage combined with some on-site solar to help decarbonize the heating process itself, and that should lower the carbon intensity by about 70% compared to the use of new or recently mined material or produced material, and overall approximately 90% reduction when you include what would have been included in the incineration of some of these emissions or other ways you would take care of these emissions as they come off the plant itself. So I mentioned the circularity. This is a way to turn waste materials or materials that would have left the site back into the process itself and make it more efficient and certainly cleaner. Next slide, please. Baytown, Texas, the Exxon facility down there. This is the project to carbon plant reduction project down there. And it's basically going to enable the use of hydrogen in place of natural gas for the facility. So a pretty sort of standard fuel switching operation. Hydrogen burns cleaner than natural gas itself, and some new burner technologies for particularly the production of ethylene down at the facility itself. It will enable up to 95% clean hydrogen fuel to be used and avoid 2.5 million metric tons of CO2 production per year, or almost half of the total plant's emissions themselves, and quite a few jobs associated with this facility also. And this is another case, by the way, of by using that switching, other pollutants also get reduced. There are criterion air pollutants mentioned at the bottom there. So it's not just a CO2 reduction, overall emissions get much cleaner with this. Next slide, please. So the TechNet Stone and Webster process technology, this is a sustainable ethylene from carbon dioxide utilization with renewable energy. Acronym is SECURE itself, and it's going to be down on the Gulf Coast itself. And it's sort of like talk about for a recapture project where you capture and recycle the emissions from some of the chemical processes and use those emissions and turn them back into products that the plant could use. In this case, in particular, it's utilizing captured carbon dioxide from ethylene production. It's capturing it through some biotech-based processes and green hydrogen, and you use that then with this reprocess to create ethanol and ethylene itself going forward. Again, some fair amount of construction jobs and some permanent jobs associated with the project itself. Next slide, please. The STAR e-methanol project down in the Texas Gulf Coast itself is a project led by a subsidiary of Ørsted, and they plan to use capture the carbon dioxide from local industrial facilities, synthesize it, and with clean hydrogen and produce e-methanol, or much cleaner methanol that reduces the overall carbon footprint of this sector itself. It's estimated to produce 300,000 metric tons of e-methanol per year, and that's use would reduce the carbon footprint by more than or approximately 80% over traditional methods for this chemical itself. You can see construction jobs and associations with local universities in the area. Next slide, please. Dow Chemical Plant down in the U.S. Gulf Coast itself. You can see its utilization of electric vehicle battery chemical production. So it's a new construction. Plans to design and construct a facility at one of its sites, and it's to capture and utilize 100,000 tons of carbon dioxide. So again, you would point source capture the carbon dioxide before it can leave the plant, and then use that carbon dioxide to produce essential components for solutions needed for the domestic lithium-ion battery production itself. So again, it's kind of closing the cycle of the production facility itself going forward. Next slide, please. BASF Corporation in Fremont, Texas. So it's a syngas production from recycled chemical byproduct stream. So excuse me, similar to some of the things we've talked about before, you recycle some of the liquid byproducts from your facility into syngas, and then it can be used as a low carbon feedstock for other operations, in particular, in this case, the Freeport operations for the company itself. They can use a plasma gasification and other forms of renewable power that allows them to replace natural gas incineration. And so that decreases significantly the carbon dioxide emissions of this site, perhaps are estimated up to 90% itself. So again, another good example of taking what normally would have been a waste leaving the plant and reusing it within the plant itself and closing the cycle. Next slide, please. Excuse me. This is the ISP chemical plant in Kentucky. It's the chemical production, electrification, heat storage facility. And so the plans are to replace the natural gas boilers with electric heat from thermal batteries or other clean sources. Should reduce the GHG emissions by about 70% for the steam generation associated with the plant itself. The heat generation, you can see there, it's some new technologies associated for thermal heat storage itself. Very replicable, we believe, and so it's a good demonstration scale for this going forward. Next slide, please. Pulp and paper. This one is the International Paper Company in Louisiana, or Mansfield, Louisiana itself. And this is a project in which International Paper is using a various separations process, and they're partnering to decarbonize the thermal process that is used in the plant itself. It's you have to use the heat within it. In particular, what's interesting about this is it's a new membrane-based technology, so it's a little bit different technology being used in the process itself than sort of traditionally used, and it has a chance to reduce 75% of the CO2 emissions from the facility when compared to other uses of water itself. So significant amount of jobs at the site there. Again, this membrane technology has a real potential to be replicably used in many different activities. Next slide, please. Aluminum and metals, and in particular, when we say metals here, is copper, is what we're talking about generally here. But we've selected 5 projects in this area, and they represent a major capital investment to decarbonize primary aluminum in this country. And it supports, in some cases, some very first used and world leading recycling approaches to these projects have gone themselves. It also, not only will it simultaneously decarbonize these processes, but it'll frankly onshore or bring back some supply chains of critical materials, particularly for defense industry and energy sector, bring those back into the country itself. And so address national security and supply chain issues associated with those. So with that, let's get into the projects. So the green aluminum smelter, the preferred site is in Kentucky, but they continue to evaluate sites in other states as well. This will be the first new U.S. primary aluminum smelter in 45 years. So certainly an exciting project itself. It plans to avoid up to 75% of the emissions from a traditional smelter that is used in this. And I mentioned some of the materials because the quality of aluminum can be used in national defense, electric vehicles, and some of the other green energy applications you see there. A significant number of jobs associated with this project going forward. Next slide, please. Beanland, North America, and it's a advanced copper recycling facility, and also in Kentucky here. And they're proposing to expand their U.S. recycling capacity and capabilities through some of the ways that they handle copper scrap metal. And so what this is by expanding the types and amounts of copper scrap and other metals you can take, this is metal that now can avoid being landfilled or lost. You can bring it back into the process. And this diverse mix of copper scrap and other metals, you can then turn into high purity copper. And so it essentially, again, another example of sort of closing the cycle. Instead of material just being wasted or go to landfill, it can be recycled in, and more of it can now be done through the processes being looked at within this project itself. Next slide, please. This low carbon smart melt furnace conversion in Ravenswood, West Virginia, Constellium. And they proposed this this zero carbon aluminum casting plant, one of the largest aluminum rolling facilities in the world. And so what it's doing is installing a low emissions furnace that can use a range of fuels, including hydrogen, which of course has no CO2 emissions associated with it itself, the hydrogen. And so it's a good example of changing the process itself to make the project cleaner going forward. Next slide, please. This is the Real Alloy Recycling is the selectee, and they're in Indiana. And the project is Zero Waste Advanced Aluminum Recycling. And so this one is an interesting one where there's a very specific waste stream, salt slag, that is going to be able to be recycled or being recycled using a recycling facility in Indiana. So it builds a processing plant on the back end of the existing facility that normally the salt slag would have to go to landfill or be wasted. And now it can be recycled back into the aluminum processes itself. And so significant reduction in the overall carbon intensity for the process is up to 95% there going forward. And you can see the jobs associated with that project. Next slide, please. Out in Colorado, Fort Lupton, just north of Denver, we have the Golden Aluminum and their next cast or next generation aluminum mini mill project itself. And it's a process that reduces natural gas consumption, improves the overall efficiency and recycling of more of the material itself. So it's kind of a combination of everything we talked about within a facility itself. It produces the upgrades to allow facility to produce aluminum products for, again, electric vehicles and other clean technologies themselves. It also, particularly out west, is important. It reduces utilizes approximately 86% less water compared to some other technologies. So that is particularly, again, out west in the US, an important benefit to this project itself. Next slide, please. So now we'll talk about heat. And as you can imagine, almost all industries need heat of some type, often high heat in the case of metals working, or aluminum, steel, etc. As you can imagine, melting temperatures and that. But there's also other industries that can use a little bit lower or medium, what they call lower or medium heat. And so this is looking at different projects that in the glass, food, and beverage areas, and just straight process heat that can be used over. And how to produce that heat in a much cleaner way. It's over $700 million investment, and collectively upwards of 1.5 million metric tons of carbon dioxide emissions can be avoided per year. Next slide, please. So we'll start with food and beverage. And so there are 3 projects in here, highly replicable. Energy efficiency and electrification solutions. And again, these are more low and medium temperatures, so not, again, melting metals and things like that, but lower locations. These are also interesting because many of these plants you'll see, there are multiple plants they have. So although it's 3 projects, it is upwards of over 10 or more actual locations in which the work will be done. So next slide, please. The Kraft Heinz, and you can see a number of locations there. It's the delicious decarbonization through integrated electrification energy storage. Might be the first time delicious and decarbonization have used in the same sentence, but I think it's very applicable considering the products that the company itself produces. Again, it's to upgrade and electrify and decarbonize the numerous processes at up to 10 facilities that are used in the various food and beverage production activities at a number of these. And it's a combination. Each plant will do something a little bit different based on the characteristics of the heat they need, based on what's at the plant now. So it might be heat pumps, might be electric heaters, some boilers, some solar thermal, some thermal storage. It'll just vary based on the plants themselves and tailored for each of the facility. But it should reduce or aims to reduce emissions by over 300,000 metric tons every year of carbon dioxide going forward. Next slide, please. Diageo Americans supply heat batteries and decarbonization of the beverage industry itself. So the company plans to replace its natural gas-fired heat with heat batteries. These are, obviously less CO2 producing themselves. And it's powered on site by renewable energy also, and electric boilers in the facilities where they're located. With these upgrades, the carbon dioxide emissions should be reduced by upwards of 17,000 metric tons every year for these projects. And in particular, these are beverage supply companies themselves going forward. Next slide, please. Unilever, decarbonization of their ice cream manufacturing at these plants here. And you can see a number of locations there. And again, it's kind of similar, reducing the use or replacing natural gas boilers with electric boilers, industrial heat pumps at some facilities, manufacturing facilities that they currently have. And these upgrades are expected to reduce the carbon dioxide emissions by upwards of 14,000 metric tons per year going forward. And again, this is a good example of, in this case, the fuel is cleaner for the energy input. So instead of natural gas, electric boilers going forward. Next slide, please. So glass. 3 glass projects were selected, and excuse me, expected to validate different types of furnaces, particularly electric fuel hybrid furnaces to produce glass in a more low emission setting itself. So let's talk about the 3 projects themselves. Next slide. One Glass Inc. in a couple different locations there in California, Ohio, and Virginia. It's the glass furnace decarbonization technology. And it's to essentially rebuild some existing furnaces at these facilities to reduce the carbon dioxide scope with the new technologies being used, 48,000 metric tons avoided per year, about a 40% reduction in scope 1 emissions or carbon emissions across the 4 furnaces and the production lines themselves. These are new, the plans are to rebuild these in much more cutting edge, newer technologies for each furnace going forward. And it's frankly, it's going to be a combination of different technologies associated with a furnace, and the first time many of these technologies have ever been implemented simultaneously within furnaces themselves. Next slide, please. Gallo Glass Company out in California itself, hybrid electric glass furnace project. And so this is a similar, and they're going to install a hybrid electric furnace. So it'll significantly reduce the natural gas, not completely, but significantly reduce it by up to 70%. And it'll increase, allow some increase in recycled or simultaneously increase the recycled glass content by 30% in the production of bottles, glass bottles themselves. It's anticipated to create some new jobs at the site, and the company certainly has a history of partnering with the community in its activities out there. Next slide, please. In project in Toledo, Ohio at Libby Glass, and this is the flexible fuel electric hybrid glass furnace demonstration. So again, as we said, all these are similar technologies, but each a little bit different, each a little bit different use case going forward. But they were planning on replacing 4 regenerative furnaces with 2 larger hybrid electric furnaces. And so it allows for more use of electricity, lower reuse of fossil fuels in the production of the heat and power, or the heat that they need. It's estimated to reduce carbon dioxide emissions by about 60% for the facilities. The hybrid furnaces also combine the benefits of oxygen fuel with the electromelting and replace about and they intend to replace about 80% of the energy with renewably sourced electricity going forward. Next slide, please. Process heat projects. So I mentioned before there's a couple projects that are producing heat that have a wide range. In fact, if there's anything we talk about here, almost all of these projects, if not all of these projects, heat is a key part of the process, whether it's metals or chemicals or food, whatever it might be itself. So finding ways to produce heat in a more less carbon intensive way, or to reduce emissions has the potential to help many industries out there. So next slide, please. Skyvin Technologies, still working out where this project will go. It's a steam generating heat pump for cross-sector decarbonization. So it's in essence, it's electrifying steam production, replacing natural gas boilers with some of these different arrays of electrified steam, and can be used for many different applications that we saw out there, and essentially reducing the fossil fuel fired heat with the electrified steam heat itself going forward. By the way, another side benefit, this is a good example again of also with replacing fossil fuels with electric heat, is the improved air quality overall for the facilities themselves. Next slide, please. And our last project, we're going to talk about Kohler Vickrell in Arizona. It's a electric boiler microgrid system itself, and so it should reduce overall carbon emissions by upwards of about 8,000 metric tons itself, and it's essentially using renewables and microgrid systems to produce the heat and to decarbonize the heat emission process, or the heat production process itself. It can be used in numerous manufacturing processes itself, and you can see there the jobs associated with this and the potential uses going forward. So with that, that's our 33 projects. I will turn it back over to Kelly to talk a little bit further.
Very impressive, Todd. 33 projects in less than 40 minutes. I'm not sure I could have done that. So now let's look at how each sector is approaching decarbonization. This is a snapshot on the next slide that shows crossover between IDP sectors and the decarbonization levers identified in the department's Pathways to Commercial Liftoff report. As you can see, the projects that we're announcing here today substantially address the decarbonization opportunity space identified in the Pathways to Commercial Liftoff report, especially in iron and steel and cement and concrete. And while we have many levers covered in the chemical sector, the diversity of production processes means that the levers demonstrated vary throughout the portfolio. That said, this is just an early start at what it will take to address the industrial sector emissions. We encourage everyone to visit liftoff.energy.gov to learn more. Now let's talk about the expected community benefits resulting from these projects. All of OCED's projects, including the Industrial Demonstrations Program, are covered by the Biden administration's Justice 40 initiative. Justice 40 creates a goal that 40% of the overall benefits of certain federal investments, including those in clean energy, flow to disadvantaged communities. I want to highlight that the 40% refers to the benefits of funding, not to 40% of the funding itself. And DOE is implementing Justice 40 through our community benefits framework process, which is a key to the success of each industrial demonstrations projects. So the IDP Community Benefits Framework has 5 interdependent parts. First, community and labor engagement, which seeks to involve those impacted in decisions that affect them and create projects responsive to the needs of communities and workers. Second, diversity, equity, inclusion, and accessibility, which seeks to help build a clean energy economy reflective of all Americans and to ensure equitable access to wealth building opportunities for all. Third, investing in the American workforce, and this is to build the skilled long-term workforce needed to power the energy transition and create quality family sustaining jobs. Fourth, the Justice 40 initiative, which I just mentioned. And fifth, the greatest benefit to the greatest number of people. And this pillar is unique to the Industrial Demonstrations Program It's consistent with language in the Inflation Reduction Act, and it seeks to provide the greatest good to the greatest number of people in the project's surrounding communities, including through the reduction of other pollutants and waste streams. Basically, we are focused on making communities healthier. Each industrial demonstrations project proposed a community benefits framework to ensure that local communities and workers are engaged in these projects from the outset and receive concrete benefits. And OCED will provide robust project management oversight of the community benefits implementation throughout the project lifecycle. DOE's engagement with communities and tribes during the negotiations begins during the negotiations, while we work with the selectees to strengthen their community benefits and incorporate input. If the projects are awarded, the community benefits will evolve as the project is developed to result in measurable impacts, and those commitments will be shared publicly. So what do these benefits look like in the actual communities? Implementation will vary by project and location depending on what is best for each community, determined by the community itself. Some examples are shown on this slide, and I won't go into all of them, but I will point out a couple. The Gallo Glass project that Todd described will support recycling education in the community and participation at local schools. The project will establish glass collection programs, including in disadvantaged communities, and provide California redemption value proceeds to support the construction of a new centralized inclusive playground. And then in the bottom right-hand corner, Todd described the Constellium Aluminum project. And this project plans to build a community benefits building with a new training and wellness center for all employees and an on-site childcare facility to support diversity. 100% of the hourly workforce of Constellium Ravenswood is represented by United Steelworkers Local 5668. And these represent just a few examples. To learn more about each project's community benefits framework, please visit the Industrial Demonstrations project webpage, and we will make sure that you have access to that link. Now that I've shared some details for each of the selected projects, let's talk about next steps and how to engage with OCED. OCED will soon begin the negotiation process with each selectee. These projects have not been awarded yet or received any funds from DOE. During the negotiations process, OCED will discuss how selectees can make their projects more robust from a technical, financial, and community benefits standpoint. If the negotiations are successful, they will conclude with OCED making an award. OCED and the selectee will enter into a cooperative agreement, which gives OCED substantial involvement through the public-private partnership. After award, the project moves into the detailed project planning phase and then into development. During the award, DOE will be actively engaging with our commercial partners and impacted communities. At this point, project scope will be more defined, so we will be able to share more detailed project information, including a summary of the community benefits framework. DOE will also ensure compliance with the National Environmental Policy Act and the National Historic Preservation Act and other applicable laws and regulations, including engagement with communities and tribes as required. Broadly, project stakeholders should expect significant engagement with OCED and potential future awardees. DOE is also exploring how regional frameworks can bolster collaboration across partners and projects to maximize benefits. Such efforts will be aligned with the OCED engagement activities. This slide shows how the high-level timeline these industrial demonstration projects will be following and highlights a few actions that you can take today to get involved. We're currently in the bottom left of this timeline where projects have been selected and will be entering negotiations with DOE. During negotiations, we encourage you to read more about the selected projects on our website, including an initial summary of their community benefits framework. In addition, we invite local community members and interested stakeholders to attend the regional briefings starting on April 15th. I will discuss these in more detail in the next slide. DOE will consider information learned during these early engagements to inform our negotiation process, which means that your feedback can help shape how projects progress. You can always share questions or comments with DOE directly by emailing engage_industrialdemos@hq.doe.gov. I want to emphasize that we are at the very beginning of a long process. These projects will take years to come to fruition and will have to pass through 2 phases before construction activities begin. For projects that successfully complete negotiations, which can take months, and receive funding in an award, there will be additional ways for folks to get involved. Projects that are awarded will go through a phased approach made up of 4 phases shown in the top right of the slide. And engagement will be ongoing through all of these phases. And one of DOE's oversight roles is to ensure that meaningful engagement continues regularly in each phase. Between each phase, DOE will assess the project's progress and will make a decision about whether the project should receive additional funding. This is called a go, no-go review. For projects that succeed in progressing to the next phase, activities for that phase, including community benefits, will be negotiated, and the commitments that come out of that process will be posted publicly on our website. This process repeats for each phase, ongoing implementation and engagement throughout the phase, a go, no-go decision at the end of the phase, negotiation of the next scope phase, and publication of commitments. And finally, in addition to these steps, all of these projects are subject to the National Environmental Policy Act, which includes robust public participation processes. These processes will occur primarily during phases 1 and 2. Now that we've shared the timeline, let's discuss one of the next steps you can take to get involved. In the coming weeks, OSED and the project selectees are co-hosting 5 virtual regional briefings to share information with communities located near project sites. These briefings are an early but important step in broadening engagement between DOE, the selectees, and the communities impacted by these projects. Although these projects have not been awarded funding yet, OSED is committed to transparency, understanding community concerns and priorities, and rapidly integrating feedback into plans. These briefings will focus on hearing from local community members, and you can register to attend the briefings through our website. We'll put that link in the chat. If you have questions about the Industrial Demonstrations Program or specific projects in your area, please email engage_industrialdemos@hq.doe.gov. Please also sign up to receive OSED news and updates. This is the best resource to stay in the know about OSED. We've compiled some resources for you to learn more about some of the topics we discussed in this session. My colleague will put these links in the chat. We will also share these slides with all registrants and post them on our website, so you will have access to these links later. And finally, thank you again for attending this session. We really appreciate you all taking the time out of your week to hear about this program and the selected projects. Please do not hesitate to reach out to us with any questions or concerns. Thank you very much.